All right, good morning, class. Mr. Burkhoff is here as your sub. Thank you for paying attention and being respectful. You guys are going to keep learning today, even though I'm not here. You're going to work on permutations and combinations. So there's just a couple quick slides before your packet, but you want to get out your packets and turn to the permutation combination page. It just says permutations and combinations. All right, so first, we want to look at the basic counting principle. It says at And Pizza they have two different crusts. So 2 different options for crusts. They have 7 different options for sauces and 20 different toppings to choose from. And if we only choose one topping, how many different pizzas can you make? So we could go like this. Okay, you have the original crust or the ancient grain. And then there are 7 options of sauces if you have that crust, and 7 options if you have that crust. So now we're up to what? 7 and 7, so 14. So 7 times 2, right? 14 options, okay. And then if we had 20 off of each, 20 different topping options, and they're only picking one option, so they would just multiply this times this times this, and the basic counting principle would work that way. So 14 times 20 would be 280. So it would be that many pizza options with only one topping. All right, so here we go. Basic important stuff is permutations, order matters, and combinations, order doesn't matter. So we were trying to come up with some mnemonics. One that students came up with in the past was palms. So if you're on palms, the order matters, right? If you're doing that wave of pom-poms and you do it in the wrong order, it's going to mess something up. Somebody else said a perm, like if you're getting a perm in your hair, it matters the order of the steps that they do the perm, or they can mess up your hair. But just a comb, like it doesn't matter what order you comb your hair in. So I don't know, it's kind of silly, but it might help you remember which one order matters and order doesn't matter. Very key, because if you use the wrong formula, then it's messing it up. Okay, so here we have NPR. This is a permutation formula. The N and the R stand for, N is just the total number of objects, and R is how many you're choosing. So say there were, oh hey, today is you're listening to SGA stuff. So say there are 10 people applying for the same position, but there's only one position possible. Or say there's 20 total, but there are, I don't even know how many officers there are. There 4 or 3? Oh my gosh. I'm going to say 4. President, Vice President, Secretary, Treasurer. Okay, we're going to go with 4. So say there are 20 applying, and there are 4 that we can choose. And in this case, order matters, because whether you're the President or the Vice President or the Secretary or the Treasurer, those are specific jobs. So that would be an order. So what this factorial means, this exclamation point is actually a math symbol. So we would take 20 factorial over the quantity 20 minus 4 factorial. So we're going to go 20 factorial, which really means 20 times 19 times 18 times 17. Oh, I should have picked a smaller number. Times 16 times 15 until we get to 1. Okay, so our calculator can do this. I'm going to show you how to do it on the calculator. So if you go to your calculator, factorial is in math, over to probability, and number 4. So math probability 4 will get you factorial. Now, I'm not sure what my answer was, so this is kind of silly. Okay, if I said 5 factorial, math probability 4, 5 factorial is the same as 5 times 4 times 3 times 2 times 1. And you get the same thing. So that is the definition of a factorial. Okay, so over here we're going to do 20 factorial, and then 20 minus 4, we do that first, so 16 factorial. And basically, this 16 times 15 times 14, this is 16 factorial. So this and this cancel out. So really I just need 20 times 19 times 18 times 17. And that would give me my answer. 20 times 19 times 18 times 17, and I don't do times 16 because that's simplified out. And that would be how many different possibilities if we had 20 people, different ways of getting them in a specific order. Yeah. Okay, so that's a quick example of permutation. Combination is similar, but if order doesn't matter, there are less possibilities. So if we do the same 20 and 4, so we're going to go 20 combination, 4, we're going to have 20 factorial. This right here, sorry, there is a typo. There's a typo not only here, but on your worksheet. So if you can fix this, the formula is n minus r factorial and r factorial. So if on your worksheet down it says A permutations, B combinations, go down to the bottom and put in a factorial after that n minus r. Okay, so we're going to go 20 minus 4, which is 16 factorial, and r factorial, which is 4 factorial. Okay, so again, this 20 is going to go 20 times 19 times 18, 17. But once I get to 16, I can stop because I have a 16 factorial in the denominator. So that'll just simplify itself out, right? Because they both just say 16 times 15 times 14. All right, but then we also have 4 times 3 times 2 times 1. Okay, and then we could simplify anything. Oh, well, that's 5, and anything else we could simplify, that's 9. But we could just type it all in the calculator if you wanted to, however you want to do it. But 20 times 19 times 18 times 17 divided by, here I'm going to simplify this one a bit, 4 math probability 4. All right, so obviously there are definitely less options. If you don't have ranking, right, so it's just a group of 4 people out of 20 people, there are only 4,845 ways to combine a group of 4 people out of 20. But there are, oh, what was our answer here? 116,280 ways to order them with a hierarchy of like first place, second place, third place, fourth place. So as far as if place matters, then there's an incredibly larger number that we're looking at. Okay, another really important fact. I want you to type into your calculator 0 factorial and see what happens. Oh, like guess, what do you think 0 factorial would be? A lot of people guess it'd be 0. All right, but why is 0 factorial actually equal to this? Hopefully you've already done it. Okay, 0 math probability for enter. What? 0 factorial is equal to 1? How does that work? Okay, so we have this little proof for you down here how this works. If I go 5 factorial, well, that's just that. Okay, 120. Now 4 factorial is the same as 5 factorial divided by 5, right? The 5 cancels out, and then you've got 4 factorial. So take that 120 and divide it by 5, and you get 24. All right, then do the same thing. 3 factorial is the same as 4 factorial divided by 4, so we do that. 2 factorial, again, do that, and we get 2. 1 factorial would be 2 factorial divided by 2, and we get 1. So 0 factorial would be 1 factorial, which is just 1, divided by 1, and 1 factorial is 1, 1 divided by 1 is 1. Kind of weird. So 0 factorial is actually equal to 1. All right, important fact you need to know. We can talk about it more tomorrow if you'd like me to prove it a little slower. All right, so you guys have this worksheet. Let's just do a couple quick problems because I need to get going. All right, permutation is arrangement of objects in a certain order. We talked about basic counting principle. Here, if there are 7 digits, 1, 2, 3, 4, 5, 6, 7. And we want the phone number to begin with 2, 8. So this needs to be a 2, this needs to be 8, this could be anything, 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 anything. As long as it starts with a 2, 8. How many 2s are there? If we think about all the digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 obviously is 2 digits. So there are 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 different digits that you could have in a phone number. So here, but if we're saying it has to be a 2, then we're going to say that, well, there's only one way that it could be a 2? Well, there's only one way that it could be an 8. Well, there are 10 options for the next. So here we had a 2, we had an 8. There's only 1, 2, 1, 8. But then there's 10 options for each of these digits, because all we want is for it to start with a 2, 8. We don't care about any of the other ones. So it could be 9, an 8, a 7, a 6, a 5, a 4, a 3, 2, 1, 0. Okay, so then we're going to multiply all these together like that pizza. The counting principle says you just multiply them together. And there we go. There are 100,000 different ways to get a telephone number with 2, 8 in the beginning. All right, how many different ways can 5 textbooks be arranged? 3, 4, 5. Well, once we put the first book there are 5 options, but once we place that, then there are only 4 options left, and then there are 3, and then there are 2, and then there are 1. So this actually is just 5 factorial, which we already looked at is 120. All right, so this is a notation. You'll also see NPN or NPR, and explains what that means. So let's check out this one. In the 1922 Olympics, 8 women qualified for the women's 400-meter relay and track and field. Only 3 women can win the medal. So there are only 3 options. How many different ways could the top 3 medal winners occur? Okay, so we're actually not going to do that. We are going to say, well, does it matter? Does order matter? That's our first question in every one of these questions. Top 3 medals. You get gold, silver, and bronze. So you have 3 different options. The order matters. So if order matters, we're talking about permutation. So we're going to use this formula right here. Okay, so there are 8 possible people, and only 3 can win. Top 3 can win. So 8P3, or as they put AP8, comma 3. Okay, and you get 8 factorial over 8 minus 3 factorial. So we get 8 factorial is 8 times 7 times 6, 5, 4, 3, 2, 1. Over. Whew. 8 minus 3 is 5 factorial. So I'm going to start right here. 5, 4, 3, 2, 1, because, well, that just cancels out, right? So our answer is 8 times 7 times 6. So we're going to multiply that out and see how many times. There are 336 ways that 3 people could win the top 3 medals. All right, so that's permutations. So combinations, again, oh gosh, this worksheet has an error on it. There is supposed to be a factorial right there. Okay, so for combinations, the order doesn't matter. It's a group. It's a group of 3 people. From a row of 8 different varieties of soup on a shelf, how many groups of 5 cans can be selected? So here we're talking about 8, choose 5. Okay, so we have 8 factorial over n. 8 minus 5 is 3 factorial. And r factorial would be 5 factorial. So there are definitely less ways of this happening. 8 times 7 times 6 times 5 factorial. I'm going to stop because I already had a 5 factorial. That's just going to cancel out. 3 is 3 times 2 times 1. I could simplify and say, oh, well, 6 and 3, that simplifies to 2 over 1. And that simplifies 2 and 2. 8 times 7, there are 56 ways, or 56 groups you could make. And that is that. Okay, so hopefully this has been enough for you to get at least a good grasp on doing permutations and combinations. If you need more assistance, you can check out in the textbook, look up in the back permutations, combinations, or you could ask your sub if he is comfortable with permutations, combinations. All right, have a wonderful day. Thank you. Make sure you finish both that worksheet with the rest of the exercises, and then permutation, combination, the next page for homework. Isn't that what the homework says? Let's see. Oh no, it actually says there is bookwork. Okay, so your in-class worksheet is the next one. It says 1 through 14, so you want to try those, but maybe try the exercises first. You'll probably get through all of this. Okay, so try exercises 3, then all of the worksheet, and then the homework is in the book. Please do not do the bookwork until you've already tried the practice problems. All right, have a wonderful day. Thank you, Mr. Burkhoff.